Hi, everyone. Welcome to day one of DevCon. Thank you for having me come talk at your conference. I love developers conferences. I love healthcare. So I'm really just thrilled to get to be here or be here virtually today. Melanie had actually just told me that the theme this year is retro sci-fi, and I really wish I could be there in person because that would be so fun. So today we'll talk a bit about technology and responsibility and what's the builder's role and how it relates to healthcare a little bit in general, where the tech sector is heading, what some folks are thinking about in terms of tech and responsibility. And I'll kick off with that by first doing a short intro about myself. You already heard a little bit of what I do, but I'll share some more details on that. And why are we even talking about responsible tech, which isn't new to a lot of you because you care about healthcare and healthcare tech and serving and caring for people in many ways. So that some of these topics may be resonant as well. What are some of the issues in tech that we see today? What are some of the levers for change? And go through a few case studies, talk about how power really lives with the builders, and share some resources. So we'll dive in. I'll start from the beginning. I'm Kathy, and this is relevant on why I got into programming. I am a trained computer scientist, and as a kid of refugee immigrants, that was not a thing that I was encouraged to do. But my senior year of high school, I had a teacher that decided to just teach me Pascal, which is a totally, for many people, unless you're in the government sphere, pretty obscure language. And the big takeaway for me was, oh, I can tell computers what to do. I can write a piece of code that can print out a receipt and control what the computer does. And at that time, it didn't occur to me, I was 18, what power that holds. And I think maybe for the tech sector, we probably weren't there yet either. We knew we could create cool stuff, but the power that we have in telling computers what to do through code, and then pair that with a world where technology and code is pretty much pervasive everywhere. So we'll get into those topics, but that's how I got into programming. I ended up studying computer science because this teacher taught me Pascal, and I wrote a receipt program. And then I cared a lot about healthcare. A big part of my upbringing was, hey, Kathy, we worked really hard to come to the United States. You're going to be a doctor or a pharmacist or something in the medical field. And I thought I might be interested in that, but I cared a lot more about the tech side of things, and I really wanted to do computer science. And I didn't really know at the time that healthcare and tech were even a thing, which sounds crazy now because they absolutely are a thing, and why Cerner exists, and it existed well before I started, and many healthcare technology existed well before I started college. But so I started exploring. I was super curious about all sorts of stuff. I did microarray analysis in a bioinformatics lab. Some of you may be familiar with Connect open source. I worked with Connect open source for a few years on interoperability, a word that we love to throw around, on how to figure out how the government can help with interoperability. I founded a nonprofit called Unite for Sight. I've worked with the Veterans Affairs electronic health record system, and then found my way to personal health records at Google Health, where I learned a very important lesson of what it looks like when a tech company brings our engineering and design and product chops and a lot of hubris to the table without maybe necessarily knowing everything that we have to know about healthcare to try to really change the healthcare landscape. So we started out with building out Google Health, and this is going to be a theme I'll bring up a little bit later of how do we really understand what healthcare is, right? Of just saying, hey, we're going to build this portal and everyone's going to use it, and we're going to connect all the different healthcare systems, and everyone can just hold their health records in the palm of their hand like they do with their email. We'll solve all those problems. And how we have to really understand the nuance of the systems and the policies and the bureaucracy and the humans involved in these really complicated systems, especially healthcare, but so many others, when we build, or else our products won't succeed, and in some cases cause a lot of harm. So that's a little bit about how I got interested in some of the healthcare work. But I think where I actually first learned about Cerner was when I was working for a couple of really large hospital organizations and did the nitty gritty, some of you are familiar with this, of ETL processes where I built data warehouses, we put data into systems, and then I extracted data from those systems, did transformations, loaded them into another system, and then did all this analysis on it and learned that data is messy and complicated and confusing. And when people throw around terms like interoperability without understanding how complicated the data systems are and the different formats, and the XML of this version might be slightly different from the XML over here, and now you just can't connect to them anymore, and how that leads to things like dropped records or patients being lost or moms not being associated with their kids, and really seeing that from the detail level of like the line by line of like a SQL database or something. And that's what got me really interested, I think, in this idea of, we have all these requirements at the high level, but it's all these little decisions we make on how we store and transform and manage the data that is also really critical. So store that away somewhere. And then I always like to sneak this slide in if I can. This is my mom on her naturalization day in the US. My mom got cancer about 6 years ago, and I found myself, and some of you probably have had this experience where you've built healthcare systems, and then you find yourself in a world where you're in the middle of so many systems you've either built or have connected with. And we were in between 8 different hospital systems or healthcare systems of some version. And then this was what, maybe a decade after I had worked on interoperability stuff, and we still couldn't get our records. And we weren't alone. I was helping others in the Vietnamese immigrant community, and this affected people's healthcare. It affected people's well-being, their ability to get their chemo treatments, their medication on time. And it wasn't just the patients. It was the doctors trying to help them, the schedulers, the people administering the drugs, this whole ecosystem where the technology itself was really hindering and getting in the way of the care that people were getting. And it wasn't intentional, right? It wasn't like any of these systems were like, we don't want to serve you. We want to make bad technology. It's just a really complicated system with lots of disparate systems put together. And at the end of the day, the user is trying to navigate everything when the tech is supposed to help. And then a few other things that I've done that I think also will inform some of what I'll talk about is I've built sentiment analysis engines. This was years ago where we used open source technology to do sentiment analysis on news and Twitter. This was right when Twitter just started, and saw the imperfections of open source sentiment analysis or text mining tools. And also saw, and this is I think important, is that even though those tools were imperfect, the moment you package them up and build something like a fancy sentiment analysis engine, they're not questioned. To the point where I submitted that product into an international competition called the Imagine Cup, and we won worldwide first place for something that was incredibly imperfect. And I'll never forget that whenever I think about any AI, machine learning, deep learning systems that are being sold to healthcare and government entities, because these tools get packaged and we might not know that some of the nuance is lost in the text, or some of the decision-making processes are not taking into account some really complicated societal issues. And the end product is just used as a source of truth. And I'll come back to that in a bit as well. Also got to see the inner workings of something like Google Search, working on that product as well at one point, and then building flight simulation software years ago. And each of these, I think in my early days, I hadn't really considered some of the implications of what responsibility and small engineering decisions really make in the day-to-day of what the software looks like in the end. And in many cases focus on all the exciting parts of like, look what we can do with the technology. This is so cool. And they all, I think, led to where I was a few years ago, running an ethical tech group at Harvard and starting up responsible computer science at Mozilla to just really rethink how we build technology and what that looks like. Some of my life goals, in addition to some of the other ones around responsible tech, is I threw this up there because it's very similar to some of Cerner's goals, which is improve healthcare through IT and think of software innovation for better healthcare, and of course, interoperability. And I threw that up there because everyone keeps saying it and we haven't figured it out yet. And I think that's in some ways okay. I recall hearing folks talk about interoperability as this big thing that we're just going to tackle right away. And when I think back to the last maybe 12 years, we see it incrementally happen, and it's not perfect. But at least now when you go to one hospital system, they're able to see some of your records from another hospital system with a different system. So we're making incremental progress, whether it's different companies working together or governments coming up with frameworks and standards that are enabling that to happen. So putting all that together, what is the responsibility of the builder's role, or what is the builder's role in responsible technology? A lot of that background and some of the research the past years has really informed some of the ideas I'll share with you all today. So I'll start off with just a couple of healthcare examples, and then a couple of broader government or broader tech examples in general. Many of you have probably seen this. This is just one of many scenarios, but this idea of death by 1,000 clicks. And what it comes back to is decisions that we make in tech and design on our alert systems, in our electronic health record systems, or in our EMRs, at some point makes it so there's alert fatigue, which ultimately leads to people ignoring alerts, which also then leads to potentially overdose of medications, or a number of other issues that where the alerts are trying to alert you. And I like this example a lot, and I've shared this with the students in the class that I teach as well, because these are decisions that we make in design and engineering, right? There may be a decision some high-level stakeholder makes somewhere, but for the most part, they're decisions that we've made in maybe some sprint somewhere. We're like, you know what, 5 alerts seems like it makes sense. And sometimes it's informed by going to talk to doctors and nurses and schedulers and people who deal with EHRs. But sometimes it's informed by what we think is right. And if we don't really understand the environments in which we build in, then we can end up with a lot of unintended consequences. But outside of healthcare, there's all sorts of examples of unintended consequences and technologies gone awry, right? These are just a few examples, but there are so many. These are some recent examples. Some of you may be familiar with Joy Buolamwini's amazing work at the MIT Media Lab, where she tested out facial recognition software. Again, software that lots of different companies are buying now to use, ranging from hiring software to governments. And it didn't recognize her face because her face was a darker skin tone, and she put on a white mask and it did. And she's done a lot of research in the field and also pushed companies to do differently. And I think that example is important because no one probably set out to create a system that discriminated against darker skin. But there were issues along the way of our product development cycle, engineering, the data we use, the models we use, that led us to that point. Similarly, you'll see right next to the facial image, this is Compass did, or ProPublica did a reporting on this tool called Compass, created by 2 data scientists, that was meant to be less biased than humans. Sold to lots of government entities to decide if decided on recidivism rates, to decide if somebody should be let go to go home or to remain incarcerated. And they found that it over-indexed for people of color and under-indexed for people who are not people of color. And if you dig more into that, what they found was, within the tool, they use processes like asking the same questions that existed on paper forms, like, has anyone in your family ever been incarcerated? Have you ever been incarcerated? And in many ways, I mean, I've done this in the past, when we make something tech or digital, we take something paper and we make it tech. Put it online. But what are we propagating when we do that? And then again, back to the other example of a sentiment analysis tool, right? The moment you build it and you ship it, how often do people actually question if what you're building or what you've sold to them is really accurate? How often do people question if the fields in the electronic health record system are the right fields? Well, you probably get questions because you all work on the tools, but for the most part, people tend to trust the technology that they're given, and these are lives that are deeply affected by these tools that either are replicating societal norms that are problematic, or they just haven't talked to enough people to say, like, hey, social worker, do you know if this set of questions should go from paper to digital? And maybe they would have brought some of that up. A few other examples that I think are relevant was there's that image right in the middle, the white one right here in the middle of, this is a screenshot of something inside the Facebook preferences, where if you buy ads, you can pick, let's say you're buying ads for your housing rental. You can pick the ethnic affinity of the groups that you want to target. This actually came into the news because it became a housing discrimination lawsuit. But it allowed people who put out ads, so unlike a newspaper ad, you can just decide what ethnic affinity you wanted to choose. And there's two issues with that, right? One, you're allowing people to just completely set aside a whole group of people. But two, what is not evident here to you if you are buying an ad is that ethnic affinity field is not decided on by any of us Facebook users. It's decided on by some back-end system at the company that determined the ethnic affinity on your behalf. So I think the two issues there are also helping people understand what's behind the information. And if you were to tie that back to maybe healthcare information, if you're a doctor looking at an electronic health record, it'd be helpful to know which of these fields are fields that the patient put in, right? And then which one the system just decided for them. So if this is the equivalent, that the system somehow decide that someone's ethnic affinity was X based on a history of healthcare issues or where they lived. And so it's so important for us to communicate to all of our users and stakeholders exactly what we're showing them. There's so many other examples on this page, but I want to go ahead and move on, because there's so many examples where by design, some of our technologies propagate societal issues or are not clear enough that they several layers later cause harm. So how do we rethink that? Where in our product development cycle, where during the sprint, where during a requirements document, where during our testing, where during our user experience research can we catch any number of these issues? Taking it away from tech a little bit, at least the digital tech, here are just some other examples that are with very tangible things throughout history. Some of you may know that even in car crash tests, it wasn't until recently that car company used more than an average Western male body, which is 171 pounds, 5'9", to test cars. So that made it so that cars just were not as safe for probably more than half of the population, because there were men who are not 171 pounds and 5'9" tall. There's a whole thing around the iPhone. It's designed for the average male hand. Zeynep Tufekci, who is a colleague at the Harvard Berkman Klein Center with me, had a great piece around how she was doing reporting in Turkey, and there was tear gas, and she couldn't take photos with one hand like she's seen so many other people do, and it's because her hand was too small. And there are so many scenarios like that. And of course, with COVID last year, you also see PPE and face shields and how, again, they were designed for an average build, but that average build also left out a large population of people. And translating that to digital or tech, how often do we hear we want to design for our power users, or we want to design for the people who use our products the most? But is that the right metric on who we think our power users are? It's also the same reason why there's images of cancer cells in the corner there. In cancer research, sometimes there's a majority of data that are also geared towards men. I worked on the Precision Medicine Initiative a few years ago, just primarily focused on this idea that we often will recommend the same drugs, cancer drugs, treatments for different people based on perhaps a common body, and that won't work for everyone. So who are we leaving out when we think of that? Oh, and the one on the left, of course, some of you may remember, if we couldn't have an all-female walk in space because we didn't have a spacesuit that fit the women. And you can't pass this section without talking about the COVID vaccine websites the past year, right? The fact that there are so many technical advances we have in this world, but we couldn't build as a nation a website where people can reliably sign up for vaccines. But we know why, right? You all work in healthcare. It's complicated. Health systems are federated. Government systems are separate. State, county, city, federal systems are very different. You have federal mandates, federal distributions, state distributions. And I bring this up because, if anything, I would shiver if anyone ever would say something like, well, why don't they just do this? Why didn't a state just put up a Google form and have people sign up for vaccines or something? And this is just a recognition that it's complicated, that doesn't excuse us from deeply understanding these systems, understanding the policy, the distribution models, the types of users. If we're going to give vaccines first to people above the age of 65, does mobile first really make sense? Does web only really make sense? Like, these are all questions that we have to ask, or else we leave out populations of people that we have to serve. So what are some of the few levers for building more responsible tech? There's leadership mandates, right? There's leadership from the top, your CEO saying, you all must do this. You must build this into your product development cycle. You must talk to these people. There's company values and culture. We see how sometimes that works out well and sometimes it doesn't. You can have companies that have really strong values, but the execution isn't quite there. There's motivations by market fit and market values. So maybe you want to get more market gains. So maybe there is an argument there for building more responsible tech that value privacy and security and personalized user experiences. Companies are toying around the idea of ethics committees, having new pre-launch review boards. I know most folks probably don't love the idea of more review boards. And also, arguably, review boards are too late. By the time you get to a review board, that's like going to your testing team or user experience team at the end and being like, so we're about to launch. What do you think people, what do you think some of the issues are? And that's too late. So internal policies, regulation, all of these are things to consider. But what I really, really am focusing on today is the product engineering lifecycle. Every single one of us as developers and engineers and product managers and designers and content writers and UX researchers, every single one of us in every part of the product, when we build it and ship it, we have to think about all of these questions of who's missing, who's not at the table, who are we serving, who are we not serving, who by design of our product will be left out, will not be able to use this, or who might be harmed by the way we design our products. So engineering and product life cycles. So what are some of these? I mean, this is not by any means comprehensive, but there are just these different aspects, right, of all of the things we build. We do sprints, we think about design, we all have to come up with metrics, we all do user experience research. We often, well, I hope you do, bring in the community perspective in some way, but are we doing it in a comprehensive way enough? Are we designing for accessibility? Are we thinking holistically about our stakeholders? So not just perhaps the group of doctors who might use our tools, but also the nurses, nurse practitioners, the schedulers, the record keepers, and not just the patients, but their caregivers, anyone who might be opening up their health records for them. Who is the whole ecosystem of the stakeholders that we have to consider? Thinking about scaling, thinking about testing, thinking about red teaming, implementing disaster response, writing our postmortems, maintaining our systems. And every single one of these steps, these are all very typical product and engineering design concepts, right? So how do we red team differently? How do we red team not just for security breaches, but also for unintended consequences and unintended uses of our product and who's missing? And how do you have people on your team to be able to actually do that kind of red teaming? How do we test differently? How do we not just test for technical exploits, but also test for more qualitative measures of how people use our products in ways that might not be how we intended. There are so many aspects, and I really believe that in addition to any regulation or leadership, we're so empowered by this ability to code and design and build that there's so many decisions made day to day, from the type of languages we use, to data models, to metrics we track, to testing tools we use, that really affect what slips through the cracks and what doesn't. So just go through a few use cases. These aren't healthcare cases, but there are a few real life cases that I think sometimes helps me frame or think about some of these issues. Let's think about something like Google Street View for safety. Again, a totally different topic area. And I think what this really taught me about was this idea of honoring the expertise of perspectives in the room. Again, in the healthcare space, we would think that when we build healthcare technologies, we also have the expertise of so many healthcare experts and patients and users, and many times there are. But healthcare tech also has a history of also not bringing in user experiences and going forward with just the tech part. And I've been part of some of those teams as well. So what might that look like in a different kind of setting? So let's say you're on a team for a ride sharing company. And the engineering team is so excited. They're like, we have this awesome idea. We're going to use machine learning, and we are going to determine a safety score for a neighborhood, because people are complaining that some of the neighborhoods that they're being dropped off in are unsafe. And so what they're going to do is just come up with a safety score with some machine learning algorithm, and I'll just put it in your app, and I'll tell drivers and passengers what the neighborhood is. And the team's like, we're so excited about this, we're going to move forward. And within this particular meeting, it was at the Berkman Klein Center at Harvard, there was a race and gender scholar, historian, a lawyer, social scientist, and a few other folks, a computer scientist, and a couple of other engineers. And within like 10 minutes, the discussion was stuff like, have you heard of the broken windows theory? And they're like, no, what's that? Well, it's this theory that you can't judge a neighborhood by the number of broken windows you see. It's really well researched. And we bantered around a little bit. And then finally, Jasmine McNeely, who's a brilliant law professor at University of Florida, just asked the really simple question of like, well, what are you safety for whom? What are you measuring safety for? And this person was like, what do you mean? Like, well, safety means different things for different people. And I threw this photo up here mainly because I'm comfortable sharing these two photos because they're both places that I've lived. One is a place where I grew up, and one's a place I lived later after college. Some people might feel safe in that neighborhood at the top left with a bunch of Vietnamese immigrants and karaoke blasting out their windows. And some people might feel safe in the bottom right golf neighborhood. And people have a different concept of safety. So even if we come up with the perfect safety score, there's no such thing, because safety itself has a different meaning. And it takes having people in the room to understand all those concepts to help us know that we can be so excited about this engineering feat of using machine learning in Google Street View. But at the end of the day, our safety score is going to not work for everyone. Another great example that's very public is what Airbnb did when the hashtag Airbnb while Black was, and it's still, candidly, it hasn't been solved, but they're doing better. They hired Laura Murphy from the ACLU, which is the American Civil Liberties Union, to come. And what they did was really different. They embedded her in the product and engineering teams, not the policy teams, to come up with some ideas on what to do. And there are policy stuff she talked about as well, but I think what really resonated was that she helped them figure out actual product decisions. So things like rethinking guest pictures. If you don't require guest pictures, which in engineering world is a pretty easy thing to turn on and off, that can really change how a reservation is perceived. If you allow more instant booking, which again is also another pretty easy thing to turn on and off, it can also really change who gets discriminated against and who doesn't and how often. So being able to translate these very human social issues down into the product level requires people in the room who deeply understand the tech and who deeply understand the society side. And this is just more of that. They created a permanent specialized product team focused on issues of bias and others. And this is just unique to the field because that team was engineers, data scientists, researchers, and designers. And at the time, lots of companies had these folks in a separate trust and safety team or team that sat aside in policy. And as you all likely know, in the engineering world, when you're in the policy or law side, unfortunately, even though those fields are just as important and critical to any company, the engineering teams don't necessarily see their perspectives as important for engineering and product sometimes. And I'll leave that as that. So one final case we can talk about is, let's talk about forms. You're like, well, what does forms have to do with responsible tech? Everything. And if anything, forms show how small decisions can really lead to big decisions. And at the Code for America Summit this year, there actually was a really great equity talk on equity in government and LGBTQ rights in government forms. And I'll just share just a few examples. Let's say somebody came up with high-level requirements up here. You've gone through your sprints. You've come up with all these Jira tickets or whatever tracking tools you all use. And now it's on us to either design or write the code. And you're making these seemingly small decisions like, I'm going to use a Boolean for gender, because why not? That seems normal, right? Like on or off, male or female, that's a decision I'm going to make. So as an engineer, we've ultimately made the decision that gender is one or two of two things. Regardless of what your view are on different gender fields, but I think it's important to recognize that as an engineer, we have that power to determine that a field like gender can be one of two things. We could also make an array or some kind of data structure that accommodates more fields, or we can choose Boolean in the absence of thinking about anything else. When we do translation and localization, this was huge during COVID. When we want to translate information on a form, a lot of teams in the absence of having resources will just use something like Google Translate, and so much gets lost in translation. You can say something like vaccines are required in one language, or and it can translate to something slightly different in another language that is really confusing. So how do we localize our products in a meaningful way? Because otherwise we can also lead to harm if it's a high stakes environment like healthcare and vaccines. Address field, something that's seemingly so simple, right? Everyone has an address. No, they don't. And so if we make, again, turning a required field on and off is also pretty straightforward and takes seconds. But if we don't think through that, we've actually now made it impossible or not possible. Or now we're going to have dirty data because someone put something in that is not true or not correct because they don't have that field. And then this goes back to what we talked about earlier. When we replica paper-based, are we also including some of the problematic questions and issues that exist in paper-based? So think of all the forms you've had to fill out in doctor's offices, or forms you've had to fill out for school or anything else. There might be problematic questions on there. And there's really no reason why we should replicate those when we go digital. So to think about all these things, forms are so heavy and loaded with so much responsibility, right? And for any of you who've gone from forms to getting data from those forms to doing extract and transforming and loading and analysis and analytics on that data, you know how critical it is for the form to really accurately display what you need to get. It could even just be the number of characters you allow in the name field. How many name fields you allow? All of that can also exclude or include people or make it easier or harder for people's records to be lost. So something to think about with forms. There's a lot written out there about forms as well. And finally, what we'll land with is power exists with the builders in case this wasn't already clear. This is what I so deeply, deeply believe in all my experience building across the private sector, the public sector, spending time in academia, in the nonprofit sector. All the other pieces have to exist too, the regulation, the leadership buy-in, but there's so much power in the people that put things together that if we also don't recognize that, it doesn't matter how much change happens elsewhere. One of my colleagues, Beth Coco, who was at the University of Washington, but then went and started a healthcare startup, said this analogy to me that I think has stuck with me forever. She was, it's like building a car. We can design all day the perfect system that has all the right pieces, that will never fail, that has the perfect everything. But when it comes to putting all the pieces together, if somebody puts a wheel on wrong, the steering wheel in the wrong place, like something wrong with the shift gear, something, then the car just won't operate well. And so the people who put all the pieces together, who build and bring them together, us, it's so critical to make sure that we understand the responsibility we have. A more technical version of that is, this is my interpretation of how to think about something like a simple spam filter years ago. So that little red thing in the middle is email. You know, all the decisions you make, if you were to design a spam filter for email, you have to decide which programming language you want to use. Maybe there's some architect out there that will decide, but even if you're the architect, you're gonna have to decide what programming language you're gonna use. You're gonna have to decide what kind of machine learning you're gonna do, supervised machine learning, unsupervised. You want to decide which type of analysis you want to use. And then you have to decide like how you want to store your data and where and which data centers, and a local data center, a native data center, an on-prem, an off-prem. All these small decisions completely play into everything from what kind of spam gets through, what kind of spam doesn't get through, where it's stored, its privacy, security, all of that. So all of us have to understand the responsibility of the tools we build because they all matter. And with that, here are a few resources. One of my favorite resources that I come back to constantly is the Equity by Design framework. And the big one that I frequently come back to is the last point, that is process as a product. All of these are important, but process itself is the product. And what that means is we can design an end product that is perfect, like some electronic health record system that is not going to fail anyone, that captures all the right information and could connect to all the systems. But if in the process of building, that process doesn't change, if we don't have the expertise in the room to catch issues that are going on, if we continue to operate as we always have, maybe moving really fast and letting things slip through the cracks, then the product itself is not going to get there, because we have to change our process as well. And we see this happen repeatedly over and over again in so many different contexts in government and tech companies and startups, where there might be an aspirational goal at the end, but the process itself and how we build is still the same. So how do we rethink our process? There's a really interesting framework that came out 3 years ago by a Midyard called the Ethical OS. It was meant for startups, but I actually find some of their concepts really useful. And it goes through different kinds of risk zones. Some of them may be relevant to you, some of them may not be, some of them are more social media oriented, some of them are not. But it goes through really interesting case studies around things like truth and disinformation, economic and asset inequalities, surveillance, data control, trust, et cetera, to really help our teams think about these issues critically and then think about how to bring them into our product design process. And there's so many books. If you go down the rabbit hole of any one of these books, you'll discover so many more books. And a few really, really great ones, Algorithms of Repression, all the ways that algorithms by design, and I'm complicit in this because I work on algorithms in search, propagate inequality, automating inequality. Virginia Eubanks, so Sophia Noble wrote Algorithms of Repression. Virginia Eubanks did a really great book around ways that when we build technologies for the public sector, we actually automate the inequality and make it worse, even if we intend to make it better. Geek Heresy is a book that I think really shifted my mindset in tech after about a decade of tech can do all the things that we're going to change the world and it's all good. Kintaro goes through many examples of building tech outside of the United States and bringing in a tech savior complex and all the ways that we consistently failed. And that applies here in the US too, right? Where do we think tech is going to save everything? And we ignore the complicated societal issues of policy and healthcare and human error and so many issues that we build our tech and we ship it and it just doesn't solve the problems that it has to solve for. So check out some of these books. There's a great framework by Kat called Design Ethically. and I highly recommend. It's just a website. There are lots of different concepts there to think about to help you think through some of these issues as well. I feel like this is my professor hat on, sharing out resources and books and giving you reading assignments. And so just to leave you with a final parting thought, it's what is the builder's role in responsible technology? It's not just on the leadership. We need them too. So we need leadership as well. We probably need some regulation, but in policy, but we've also seen years of what it looks like when government tries to regulate or standardize and put policies around healthcare, all with good intent, but execution is really hard. A lot of it lies in our hands. What does it look like when we design these systems, when we write our code, when we create standards, when we create new XML files that fit or don't fit standards, when we make some small deviation in some of our healthcare files so that now another healthcare system can't take it in? Where are all of our roles to build responsible technology? It takes all of us, and you all are doing some of the most important work in the world, working at Cerner, building healthcare systems, thinking about interoperability and population health and electronic health records. I admire you all so much, and I'm grateful that you're there thinking about innovating healthcare. And thank you for having me here today.